Hello and welcome to another Aldic Riviera-PRO video. My name is Chantel, and the topic for this video is plots. The plot tool provides different plot styles that can be used to display a graphical representation of functions or relations among variables, present values of objects as a function of time or even other variables, and all the like. Plots can be a powerful debugging tool as it appeals more to how humans are able to process and see data. This could be useful for cases such as analyzing memories for image processing, looking at beam intensity data for ultrasound beamforming in medical imaging, and visualizing trajectory in digital positioning systems. So let's take a look at how to use the plot tool. Riviera-PRO provides 4 different plot styles that you can use to visually represent your simulation data. These plots are simple, polar, vector, and histogram. To create a simple polar or vector plot, go to View in the main bar, Debug, and then Plot. From here you can select which plot style you'd like. Once you select any of the 3, it will lead you to their specific creation wizard. For any of the 3 plots, you'll need to select a source type of either a simulation object or an external file. As a side note, if you select object as your source type, make sure that you have your simulation initialized. Otherwise, you will not have any objects to choose from. Then you'll need to select your X and Y axes, or your angle and radius coordinates if you're creating a polar plot. After selecting your axes or coordinates, you could specify triggers that can occur. You'll then be able to adjust the plot's style, like giving it a name and even choosing the color and line styles. And finally, you can set limits, which allows you to specify the range of indexes and events of the object presented in the plot document. Once you're satisfied with your settings, click on Finish, and a new plot will be created. If you want to create a histogram, you'll head to the same View tab, Debug, and then Histogram. A blank Hist window will pop up, and then you can click on New Plot to start creating. The creation process is similar to the other 3. First, select your source type, then specify the object for the histogram. The next window then allows you to specify your bins, and then just like the other 3 plot styles, you can specify triggers, style, and limits. So this is how you would create a new plot. Now I'll demonstrate what each plot would look like. Currently, I have this plot design open. This is a sample design that you can access and use by going to Riviera-PRO's Examples folder, Tools, and then Plot. The first plot style I'll show is the simple plot. This plot type presents strings of one-dimensional data samples on 2-dimensional graphs. It's useful for drawing connections between elements in 2 vectors or data samples, as well as relationships among subsequent vector elements, or input data in the time domain. This can be especially useful for DSP projects. I'll be running the project runme ASDB macro. This macro uses commands that sets the simple design as active, compiles, initializes, and runs the simulation, opens the array 1KB waveform and the simple 1KB plot file, sets and pauses the simulation time, and rebuilds the plot every time at these 3 time intervals. Opening up the plot file and looking at the plot's properties, this macro has the 1 kilobyte array simulation object as the Y object, with its index being the X object. As you can see in the simple Verilog file, each index of the array stores a different value depending on the index value. So now let's go ahead and execute the macro. And now we have our final plot of our simulation results. But let's look at the waveform results first. While we can see the numerical data as simulation time progresses, this might not help us fully understand what the array is producing. Now looking at the plot, we can visually see the association of the data assigned to each index of the memory array. Notice that the plot toolbox is also opened, If it's not already opened, click on this icon inside of the plot window to access it. Here you can have multiple plots, and you can choose to hide or lock plots. And you can also select the plot and show its properties. This is where you can make some edits to the plot, like the settings that you set in the plot creation wizard. If you're stepping through your simulation or changing values of your plot axes, you can use this Rebuild button to refresh the current plot to reflect the changes. I'll now go ahead and stop the simulation, close my plot and waveform windows, and close the files for the simple plot. Now let's move on to the polar plot. These plots are similar to the simple plots, but instead they present data on a polar coordinate graph. This graph can be useful for presenting medical imaging data like ultrasound beamforming results, like I mentioned in the beginning of this video. In this designs macro, it sets the polar design to active, initializes and runs simulation, and opens the polar plot. Inside of the polar plot file, there are 3 different types of polar plots. One uses the circle simulation object. Another uses the trig fun object. And the last one uses the spiral object. I'll now execute the macro. And here are the results of the simulation. This gray polar plot reflects a circle, which matches the constant radius assignment value inside of the code. Trig fun creates this 3-petaled shape using sine and the index value. And lastly, using the index value of angle range 4 pi, this plot displays a spiral. I didn't mention this earlier, but in the plot window, another useful property it has is this tooltip pop-up that appears whenever you hover over a particular part of a plot. This tooltip shows the name of the plot it comes from, the axes or coordinate values, and the index value or simulation time. This way, you can have a visual and quantitative display of information about the plot. Had we used a simple plot or used a waveform to view this data, it wouldn't be as easy to interpret as seen here. So, polar coordinates in this case are a better fit. I'll stop simulation and close everything once again. And let's go to the vector plot design. A vector plot creates a graph of a parameterized function of 2 variables and has the ability to show the order of points on the graph. This is particularly useful for designs like for actuator trajectories of CNC systems in order to see if movement trajectory corresponds to the projected pattern. The example vectors design macro sets the vector design as active, compiles and initializes the design, runs simulation, opens the vector plot file and a waveform window, and rebuilds the plot after every simulation time step specified. The vector plot file contains 2 plots, JIT spiral and circle. JIT spiral uses the x-chord and y-chord objects, while circle uses the circ x-chord and circ y-chord objects. You can see that these objects are arrays of real values that are assigned these values depending on the index of the array. Now I'll go ahead and click on Execute Macro. Notice how at each 1-second pause the vector plot updates. And now we've reached the end of our simulation with our final results. As you can see, the lines of the plots have arrows indicating its directionality on the graph. If you take a look at the waveform viewer, we get our coordinate results, which you can also see in the plot by hovering over the graph at a certain point. We can see the numerical values, but like I mentioned earlier, if this was for a CNC system, we would not be able to quickly determine if the projected trajectory pattern was met. But you can see that the vector plot displays a clear visualization of the trajectory pattern, which again is a lot more useful than the numerical values from the waveform viewer. I'll now close this project workspace. And now I'll open a new example from underneath Histogram called Frog, also located under Tools in the Examples folder. This example design also contains a README if you're interested in experimenting further. For this example, I'll be using the VHDL version of this design and only the Project RunMe intensity macro. As a quick review, a histogram is another plot style that is a bar graph that displays statistical data. The horizontal axis presents the ranges of the sampled values, and the vertical axis shows the number of occurrences of these ranges. This can be useful in image processing projects where you'd like to see if the result of the image operation reflects expected values. In this example, we'll be using the histogram plot to get the number of occurrences of the red bin values before and after intensifying the red channel of the bitmap image's RGB. The intensity macro sets the VHDL design active, sources the bitmap file, compiles, initializes, and runs simulation, opens up the image viewer to view the before and after image results, and opens a histogram plot with the red channels from the before and after images set as the objects of each histogram. Now I'll click on Execute Macro. The image viewer results pops up. Then we get our histogram for our red values of the initial image, and after a little bit of time, the plot updates again, but now with the red values intensified, coming from the new resulting image. In the plot toolbox, we can see how the two histograms are labeled, and like the other plots, you can adjust their properties. The plot window has a key at the bottom to distinguish the different histograms. In the image viewer, you can see that the intensify operation did in fact make the bitmap image redder all around. The histogram reflects this because the bin values indicate the intensity value of the red channel from 0 to 255. And as you can see, the bin values of intensity red are shifted towards the right, meaning that all the RGB values of the bitmap image have increased their value of the red channel, resulting in the redder image you see in the image viewer. And there you have it. These are the 4 different plot styles Riviera-PRO offers for your simulation data results. Despite how useful the waveform and memory viewers are, the plot tool provides a powerful insight into your design when debugging. If you have projects revolving around image processing, digital filters, or DSP systems, rest assured that plots will make your debugging less complicated, more effective, and put less strain on the brain. Thank you for watching.